Hello students, today I am going to discuss Cambridge O-level chemistry paper 42 ATP alternative to practical year May-June 2023. Cambridge O-level chemistry May-June 2023 paper 42. Let's move. Please subscribe, like and share my channel. Number 1. A student investigates the rusting of iron, rusting, hydrated iron 3 oxide, and figure 1.1 shows the apparatus the student uses. This is experiment A, experiment B, experiment C. 3 experiments have been done. Now number A, name apparatus X. This apparatus, you can write test tube or boiling tube, you get marks. B, state why a stopper is used in experiment B. This is a stopper. Why used? Prevent entry of water vapor. So here dry air does not contain any water vapor, iron nail. So if you give a stopper, any moisture, any water vapor does not enter into the test tube. So what the purpose of a stopper in B? Prevent entry of water vapor. Next, C, state why the water in experiment C is boiled before use. Boiled water does not contain any oxygen, dissolved oxygen. So to remove dissolved oxygen, if you boil water, oxygen will be removed. D, state why a layer of oil is used in experiment C. Layer of oil, you see, this is the oil layer, iron nail, water. So function of oil layer to prevent entry of oxygen. Oil layer prevent oxygen getting into, or oxygen cannot enter into the test tube through the oil layer. So what the function of oil layer? To prevent entry of oxygen. Oxygen does not enter. Now E, the experiment are left for 1 week. Predict in which of the experiment the nail will have rusted. Only the nail A will rust, because both water and oxygen are needed for rusting. Condition for rusting, water and oxygen are needed for rusting. So only the nails in A will rust because both water and oxygen are needed for rusting. Experiment A, you see water present, so is open, oxygen also present. So two conditions present in experiment A. So in experiment A, this iron nail will rust, but B will not rust because dry air, there is no water. C will not rust. Why? Water present but oxygen is absent. This is rusting experiment. Now Number 2, aqueous ammonia is a solution of ammonia gas. You know, ammonia gas dissolved in water to produce ammonia. A student, 2 samples of aqueous ammonia A and B. Concentration is 0.500 mole per dm cube. With a student investigates 2 samples of aqueous ammonia A and B with 0.500 mole per dm cube hydrochloric acid. The student does 4 titration, 2 with A and 2 with B. So this is the titration procedure. Now you are asking figure 2.1, this shows the burette reading for the 2 titration with A. This is the 2 reading, titration 1, titration 2 with A. Now complete the table with the volume of this. You see titration 1, this titration 1, titration 2, initial burette reading, this is the initial, you see 0, water meniscus, liquid meniscus is 0, and this is the final 15.2, you see 14, 15, 1, 2, 1, 2, this one small division is 0.1, so 2 small division 15.2. Now volume used, how much volume is used? Final burette reading minus initial burette reading, 15.2 final, initial 0.0, so if you subtract you will get 15.2 volume added. Now you see titration 2, titration 2 initial burette reading, initial burette reading is 15.2, 15, then 0.1, 0.2, this meniscus 15.2, and final 30.2, 19, 30, 30.1, 30.2, 2 small division. So if you subtract final burette reading minus initial burette reading, you will get 15.0. This 2 titration readings. Next, this figure 2.2 shows the burette reading for one of the titration with B. This is a result for titration, second titration with solution B. Now you see this titration 4, so initial burette reading 0.0, 0.5, 0.6 here, 6, 0 to 1, 6 small division means 0.6. Then finally you count 34, 35.5, 35 and 36 middle of the position, 5 small division, so 35.5. Then you will get volume added or volume used, final burette reading minus initial burette reading, so you get 34.9. Then titration 3, these 2 values are given, initial 0.02, final burette reading 34.9. so volume used, how you get? Final values minus initial values, 34.9 minus 0.2, you will get 34.7. Now explain why the student uses a white tile in this titration, and you know, if you use white tile you can to observe endpoint more accurately. You write here to observe endpoint, to observe endpoint means neutralization point, to observe endpoint more accurately. If you use white tile you can see endpoint when color changes happen more accurately, you can observe. And number D, calculate the mean volume of 0.5 mole per dm cube hydrochloric acid needed to neutralize 25 centimeter cube A and B. You see mean volume of acid needed for A 15.1. You will get this value from table. Here for A 15.2 plus 15 divided by 2, so it will be 15.1. Then mean volume means average volume of acid needed for solution B. You will, this result is for solution B 1 addition 34.7 plus 34.9 divided by 2, then you get 34.8. This is the mean volume of acid needed. Now E, the equation shows the reaction between ammonia and hydrochloric acid, neutralization reaction, ammonium salt. Use the mean volume of acid needed to neutralize 25 centimeter cube of A in D to calculate the concentration of ammonia in A. And okay, you see number of mole of hydrochloric acid, concentration 0.5, volume 15.1 divided by 1000. This is for solution of A. Moles of HCl, number of moles of hydrochloric acid, concentration times volume. Volume average value is 15.5 divided by 1000 converted to dm cube. This mole. So moles of hydrochloric acid 1, moles of ammonia also will be 1. Now moles of ammonia will be this mole. Then concentration of CONC means concentration of ammonia, N equal CV, so C equal N by V. I mean concentration equal number of mole divided by volume. So number of mole you calculate here, volume is 25 divided by 1000, it has been converted to dm cube. So you will get concentration of 0.032 0.302 mole per dm cube. This is the concentration of ammonia. Now F, calculate the volume of ammonia gas measured at room temperature and pressure dissolved in A, 25 centimeter cube of A. So the volume of 1 mole of gas is 24 dm cube, molar volume. So you calculate already number of mole of ammonia 0.00755. Here you calculate here moles of hydrochloric acid equal moles of ammonia because their mole ratio 1:1. So moles of ammonia 0.00755. Now volume, number of mole times molar volume 24. Volumical number of mole into molar volume, you will get this dm cube 0.181 dm cube. Now G question G, use your answer to D and F to calculate the volume of ammonia gas measured at RTP dissolved in 25 centimeter cube of B. And you see B mean volume is 34.8, so 15.1 centimeter cube contains volume 0.181 dm cube. So 1 centimeter how much, and 34.8 centimeter how much volume contain, you will get 0.418 dm cube. You get the answer. Now the student rinse the burette with 0.500 mole per dm cube hydrochloric acid immediately before it is filled. Rinse with hydrochloric acid. Explain why the student should not rinse the burette with distilled water immediately before it is filled with 0.5 mole per dm hydrochloric acid. Some water remains in burette, so hydrochloric acid is diluted. If burette is rinsed with water, some water will remain in burette, so hydrochloric acid will be diluted. When water present, concentration of hydrochloric acid will be less. I mean hydrochloric acid will be diluted. I suggest why universal indicator is not suitable for use in this titration. And you know, universal indicator have different pH. If pH 1, it shows one color, 3 one color, that means universal indicator shows different color in different pH, so you does not have a clear endpoint. If you use universal indicator, you will not get a clear endpoint, clear neutralization point you cannot detect. Let's move next. Number 3, a student investigates solution W and solid X. Solution W and solid X. A solution W is a green in color and contains iron 2 ion. Iron 2 solution is green, you know. Now 1, describe how W can be shown to contains iron 2 ion, and you know, test for iron 2 ion you already know. Sodium hydroxide solution is added, iron 2 ion, iron 3 ion. You can test, reagent is sodium hydroxide solution or aqueous solution. So sodium hydroxide solution is added. If you add sodium hydroxide, you would see green precipitate, green PPT, insoluble in excess, and green PPT is insoluble in excess sodium hydroxide. This is the test for iron 2 ion. Test, sodium hydroxide is added, you would see green precipitate is formed, and this precipitate is insoluble in excess sodium hydroxide. So you will get the result of iron 2 ions. Now excess W is added to acidified potassium manganate 7. Describe the color changes seen. Potassium permanganate is purple. 2 yellow. Why? Because iron 2 ion, W solution contains iron 2 ion. Iron 2 ion oxidized to iron 3 ion. Oxidized to iron 3 ion. Iron 3 ion aqueous solution is yellow color. So observation will be purple to yellow, because potassium manganate 7 oxidizes iron 2 ion to iron 3. So iron 3 ion solution is yellow color. Now number 3, describe the observation made when a few drops of aqueous ammonia and then excess aqueous ammonia are added to the mixture from 2. Here 2. So 2 contains iron 3 ion, because iron 2 ion oxidized to iron 3 ion by potassium manganate 7. So now if you add ammonia, means ammonia, aqueous ammonia means ammonium hydroxide. So iron 3 ion reacts with hydroxide ion to produce iron 3 hydroxide. Iron 3 hydroxide is a brown precipitate. Iron 3 hydroxide is brown precipitate, and an excess insoluble in excess. If you add excess, iron 3 ion reacts with hydroxide ion to form iron 3 hydroxide, brown precipitate. If you add excess ammonia solution, this precipitate does not dissolve. I mean, precipitate is insoluble in excess. Then B, solid X is a shiny gray metal. And the student does on X shown in table this. Some of the observations for this test are also shown. Test on solid X. Solid X is a shiny gray metal. Observation you get. Test 1. An excess dilute acid 2X is added, and metal reacts with acid to produce salt and hydrogen. The gas produced is tested. Gas is hydrogen, so hydrogen pops with a lightened splint. Now you are asking, A, predict the identity of the gas produced in test 1. Describe how the student tests the gas to confirm its identity. Any metal reacts with acid to produce hydrogen gas, so gas will be hydrogen. And test burning splint. Observation to confirm gas pop sound. I mean, hydrogen pops with a burning splint, with a lightened splint. Now the observation for test 1 are incomplete. Now state one other observation that the student makes for test 1. When metal is added to acid, hydrogen gas is produced and fizzing occurs, effervescence. When any gas produced from in liquid, effervescence, or you can write bubbles or fizzing. Any word you can write. Fizzing, bubbles, fizzing, effervescence. 3. State the conclusion you can make from test 2. Test 2 result is there are no halide ion present. Why? You see test 2, you did add dilute nitric acid, then add aqueous silver nitrate. You know, nitric acid and silver nitrate are used to test halide ion, chloride, bromide, iodide ion. So solution remains colorless. No precipitate is formed. Solution remain colorless means so there is no chloride, bromide, iodide ion present. Test 2 conclusion is halide ion absent. Now your result you write there are no halide ion present. Then 4, state the conclusion you can make from test 3, sulfate ion present. And you see the test 3, add dilute nitric acid, then add aqueous barium nitrate. And you know, barium nitrate, barium chloride reagent is used to test sulfate ion. So as white precipitate is formed, so sulfate ion present. State the conclusion you can make from test 3, sulfate ion present. Now identify the acid used in test 1. As you got hydrogen gas produced means from hydrogen ion, and also you get here sulfate ion. So hydrogen ion and sulfate ion combine, so acid will be sulfuric acid. That acid will be sulfuric acid. Then 6, suggest the identity of metal X. So metal gray, it will be maybe zinc or magnesium. Suggest the identity of metal X, so it will be magnesium or zinc, gray metal. These are because these metals are reactive, more reactive than hydrogen. Thank you very much, dear student.